Hello and welcome back. We have seen on the particular dataset we have taken, an imbalanced dataset, the accuracy score is not correct. And we have tried to understand how the confusion matrix works. Using confusion matrix, we can calculate more sophisticated metrics like precision, recall, and F1 score. If you look at the confusion matrix one more time, there is a notation called true negatives, false positives, false negatives, and true positives. If you look at these 30,444 records, they are not belonging to 5 and model predicted them as not belonging to 5. That means true negatives, truly predicted as negative. They are belonging to negative and the model also predicted as negative, true negatives. If you look at these 134 records, it is false positive. The model predicted falsely as positive. They belong to negative records, not 5s, and the model predicted as positive. And if you look at the false negatives, falsely negatively predicted, it is belonging to positive 5, the 1, right? The target variable is 1, and the model predicted as 0, false negative, falsely predicted as negative. It belongs to positive, falsely predicted as negative. It is Fn, false negative. And if you look at this 2320 records, they belong to positive and the model also predicted as positive, truly predicted as positive. So using these four numbers, we can actually calculate precision and recall. Let us see what they are and how you can theoretically understand, and then how you can actually practically do it using code. So precision is out of your positive predictions, how many are correct? If you look at the confusion matrix, this is positively predicted number of records. This is also positively predicted number of records. But out of these, only these are correct, right? Out of 2,454 positive predictions, 2,320 are correct. That means 0.945, 94.5% precision is there. When you do any activity, we say the precision is 100% if you are doing it with 100% accuracy, right? The same thing we are trying to measure here. On the positive class, we are focusing. The precision is focusing on the positive class. How many positive predictions are correct? That is precision. Out of the positive predictions it made, how many are correct? Okay. So TP, true positives divided by true positives plus false positives in this direction. And if you look at recall, it is calculating out of total positive records present in your dataset, right? If you see this, 702 plus 2320, that is 3022 positive records are present in train set, out of which the model predicted 2320 records correctly. Out of the existing positive records in the dataset, how many are being predicted correctly? That is being calculated by recall. Precision calculates out of positive predictions how many are correct. Recall calculates out of existing positive records how many are correctly predicted. So using these two scores, you can understand better how the model is working. Out of positive predictions, 94% are correct. Out of total existing data, 76.7% it is predicting correctly. So it is, there is a lot of room for improvement in the area of positive class predictions. So these are called as precision and recall. And when you have two metrics, right, the precision and recall two metrics, maybe comparing multiple models is going to become difficult. In our model building process, we take the dataset, split into train and test, then train the model on train set, test it on test set. When the model is working good, you actually move it to production. If the model is not working good, you may choose another algorithm. Model selection approaches. You may choose multiple algorithms. So here we are using SGD regressor classifier, which is based out of logistic regression. Maybe we may build another model with SVM. We may build another model with random forest. and try to choose which one is the best. The model, whichever is the best, we try to choose that and put it in production. So to compare models, right, the precision recall 2 scores will be a bit confusing. So F1 score will be handy in understanding whether a model is the best or not. So if you look at the F1 score formula, it is dependent on precision and recall scores. If you look at F1 score, it is 2 by 1 by precision plus 1 by recall. It is called as harmonic mean of precision and recall. So when you calculate the F1 score, it gives you 84%, 84.7%. For logistic regression, you have got 84.7%. For the SVM, you may get 82 point something. For random forest, you may get 90. So you choose random forest as the best model. So if you see how this F1 score works, it actually tries to squeeze or pull the highest score towards the lowest score. If you look at this, the recall is less and precision is high. And when you calculate F1 score, it reduced, right? It actually came in between the 76 and 94%. If you look at an example here, you suppose that there is a precision 0.9 and recall is 0.1. If you try to calculate F1 score, the ultimate score is going to be 18%, because if you see this 2 by 1 by precision plus 1 by recall, when you calculate it becomes 0.18. So it is actually squeezing towards the lowest score. It is actually trying to give you an impression that how the model is working. If you take normal average of precision and recall, it may not be more appropriate. If you take normal average of this precision and recall scores, it's going to be 0.9 plus 0.1 divided by 2. It's going to be 0.5. Right? It is actually showing a higher 50% accuracy. But when you calculate F1 score, it is actually coming close to 0.1. That means the model is still not working well. So F1 score gives you more clarity on how the model is working than the normal average. Right? This is called as harmonic mean. Right? F1 score is called as harmonic mean. So on an imbalanced data set, you always try to look at the precision recall and F1 scores and try to decide whether model is working good or not, and try to compare other models and choose a model, choose the best model. And now let us try to see how to programmatically do it. Right? In scikit-learn, we have got the recall score, precision score and recall score methods, which actually take your actual Y and the predicted Y. Right? Actual Y and predicted Y. When you try to calculate these two, 94% precision and 76% recall. 94% precision means out of all the positive predictions, 94% are correct. If 100 records it predicted as belonging to 5, 94 are correct. And 76% recall means out of 100 records present in your data set, it is predicting 76 only correctly. 25 predicted wrongly. Positive records. Okay. So to calculate F1 score, there is a method called F1 score, and that also takes the Y value and the predicted Y value, and then calculate the F1 score. I have got 84% F1 score. The bottom line here is the precision, recall, F1 score, all three measures are using the confusion matrix as the basis. When you call precision or recall or F1 score, it generates the confusion matrix and uses those values present in the confusion matrix, and then tries to calculate the F1 score and precision and recall. Precision, recall, and then F1 score. So that's all about the metrics on binary class classification. And in coming session, we will try to understand which measure should be used. Thank you.